Welcome to Function Review. The first question I want to review is, how do you know if a relationship between two variables is a function? In this case, we have a parabola. The definition of a function, and you'll see this in the first blank here, a function is a relation in which one element of the domain is paired with exactly one element of the range. In other words, each x is paired with exactly one y, or each input is paired with exactly one output. You put something into the function, you get a unique element out. So let's look at this function up here. If you look at the table of values, -2 is the x value. It's paired with exactly one y value because we don't see -2 being paired with anything else but 4. -1 is paired with only 1. And so from this table of values, it looks like each x is paired with exactly one y. If we look at the graph and we start at any x value, we see that in each x value is paired with exactly one y value. This is known as the vertical line test. You might have recalled that from Algebra 2. So this is a function. Every element of the domain, which are the x values, is paired with exactly one element of the range, which are the y values. Now something students tend to forget is what all of these terms mean. So I want to introduce to you my cousin who's from, well, I hate to say this, but she's kind of a hillbilly, but she loves to talk about domain and range. So let me introduce you to her, and she's going to share with you an acronym that will help you to remember domain and range. Hey y'all, my name's Dixie. I'm from Kentucky. Don't hold that against me, please. I want to share with you about domain and range, which is my favorite topic in math because it is an acronym that goes with my name. My name is Dixie, and it's spelled D-I-X-I, no E, just D-I-X-I. And D stands for domain. Another thing that goes along with domain is the input variable in a function, so I put input. Or we often call that the x variable. So the domain is the input variable, or I'll say inputs because it's all of the input variables, or all the x variables. We also call this x variable the independent variable because we pick it and then y depends on x. So this is the independent variable. So I want you to remember that Dixie, D-I-X-I, stands for domain, which is the set of all the inputs, or the x variables, or the independent variable of the function. Now, I have a cousin, and my cousin's name is Roy Dwayne, but we call him Roy D because there's other Roys in the family, so to distinguish him from his daddy, who is Roy P, we call him Roy D. So Roy D, Roy Dwayne. And his name also is an acronym. It stands for range. You guessed it, you guys are so bright. Range, which is the set of all the outputs in the function, or the output variables, and those are what we usually call the y variables, or the dependent variable of the function. Wasn't that fun? I love talking about domain and range. Well, I'll give you back to Mrs. Taylor now, but don't you be surprised if I show up in class now and again. Thank you very much. Thank you, Dixie. That was very helpful, and hopefully all of you will remember domain and range a little better now. Now we'll talk about some examples of domain and range in a minute, but I want to talk about notation of functions. So here we have 3 different ways that functions can be denoted. We have y equals x squared, where we just use x to represent the input variable and y to represent the output variable. We have f of x equals x squared, where we are using function notation, and the input value goes in this little parentheses here, and then we say, what do we do to x? F of x means a function of x, and this is known as the function rule here. And then we have y equals f of x. Y is a function of x. And that makes sense because if y equals x squared and f of x equals x squared, then it makes sense that y equals f of x. So in other words, I can replace f of x with y or vice versa when I'm writing a function. Okay, now let's move on to the next page and do a little practice with some of these concepts. State whether each one of the following is a function and then state its domain and range. So let's look at the first one. Example 1, does each value of x correspond to only one value of y? Well, no. If I picked this value of x, I can see that it would correspond to two different values of y. So it is not a function. And that didn't turn out terribly well when I drew that, so let me try that again. Okay. So one value of x corresponds to two values of y. So it is not a function. Now in the second example, we have each value of x corresponding to just one value of y. So yes, this is a function. In example 3, we only have one possible value for x, and it corresponds to multiple values for y. So x corresponds to an infinite number of y's. So no, this is not a function. And in the last example, yes, very similar to the parabola we looked at on the first page. Each x has one y, so yes, this is a function. Now, what are the domains and ranges of these functions? The domain of the first function is all the possible x variables that are represented by the points in the function. So if we look at all these different points on the function, we notice that none of the x values are negative. In fact, the lowest value that x can be is 0. So we say that the domain is x is greater than or equal to 0. Now if we look at the range, notice that we have positive values for y, and we have negative values for y, and we also have 0. And if we assume that this has arrows on it, meaning that it's going to continue to go outward, that means we're going to continue to get even higher and lower values of y. So our range is all real numbers. Now if we look at the second example, the domain is all of the possible x values. So once again, we're thinking here we've got an arrow on either end. The graph is going to continue to extend this way. It's going to continue to extend this way. So we see we have positive values for x, we have negative values for x, we have x equals 0 when we're at this the y-intercept here. So we have all possible values for x. So this is all real numbers. Now when we look in the y direction, however, notice in the y direction we don't see any negative values for y. We only see positive values for y. Now the question is, does y equal 0? I'm going to tell you no. In this case, the x-axis is an asymptote. This is an exponential function. The graph approaches the x-axis but never touches it, so our range is y is greater than 0. In example 3, our domain is only one number, x equals 3. There aren't any other values for x. Every point on this function has an x value of 3, like 3, 2, 3, negative 3, etc. Now, all possible y values are accounted for because we have positive y values, we have negative y values, so the range is all real numbers. You might want to pause the video now and see if you can write the domain and range for example 4 just to make sure you've gotten the concept. Okay, let's check this out. Domain, we have positive values for x on this side, we have negative values for x on this side. Notice that all of these values here are positive values for x, all of these are negative values, and we have x equals 0. So the domain is all real numbers. The range, it looks like the lowest possible value for y is 1, and then all of the other values for y are greater than 1, so we have y is greater than or equal to 1 for our range. Now one last little bit here about evaluating functions. If we want to evaluate a function, so let's say here's our function, f of x is equal to 2x plus 3. This is known as the function rule. the function is f, and when we say f of x, this is the number we're putting into the function. So let's say x is equal to 2. This is equivalent to having a little machine where we put a number into the machine does something to the number, and it spits another number out. So when we put a number into our little machine, it multiplies that number by 2 and then adds 3, so it spits out the number 7. So we say f of 2 is equal to 2 times 2 plus 3 equals 7, or f of 2 equals 7. That means that the point 2, 7 would be on the graph if we were to graph this function. Notice that f is not a variable, and f of x does not mean f times x. So this is a quick review of some basic function characteristics. We'll be adding to this more by talking about other function characteristics later, but this should get you started.